Welcome to Ask and Learn.
Okay, so here we're given that f of x is big O of g of x, and that g of x, and g of x is big O of h of x. Okay, so we want to show then that f of x is also big O of h of x. So, since f of x is big O of g of x, we know by the definition of big O that the absolute value of f of x is less than or equal to some constant c1 times the absolute value of g of x when, say, x is larger than some k, so we'll call that k1. And similarly, by the same definition, we know that g of x is less than or equal a second constant times the absolute value of h of x when x is larger than some other k, right? So we'll call this one k2. All right, and so for convenience, right, we will choose, say, let x be larger than whichever k is largest. All right, and we'll choose a c such that it is equal to the product of c1 and c2. Then, from above, we can sort of rewrite this. We get that the absolute value of f of x is going to be less than or equal to c1 times the absolute value of g of x. So far I've just copied from above here the definition of f of x being big O of g of x. Okay, but we know that g of x is equal or less than or equal to this thing, right? So we can plug that in for g of x. So we know that this then must be less than or equal to c1 times the absolute value of c2 times the absolute value of h of x Okay, and we can pull out the c1 and c2, right? So this then is going to be equal to c1 times c2 absolute value h of x. Okay, but we have that c is equal to this, right? So that means that then f of x must be less than or equal to c times absolute value of h of x. And that completes the proof.